All right, we're moving into our last section for test 2. This is section 2.6, and this has a variety of other types of equations. So for number 25, we're asked to change each rational equation to a quadratic form. So what we want to do is we want to clear fractions. So if we think about an LCD, we don't have a denominator for the 1, so we have an x. And then we can think of x squared as x times x. So that means I need another x. So my LCD is going to be x squared. Now I do have x's in my denominator, so I do have a restriction. In this case, it's just 0 itself, so I can't get an answer of 0. All right, so I want to clear my fractions out, so I'm going to multiply every term by x squared. All right, so if I take a look at that, x squared times 1 will just be x squared. If I multiply x squared to 10 over x, one of the x's cancels, and I'm just left with 1x. So I have a minus 10 times an x. And then for the last term, the x squareds cancel, and I get minus 24. So notice once I cleared fractions, I got a nice, pretty quadratic. It's already in standard form. I do need to be a little careful if I factor this. So I'm looking for numbers that multiply to make 24 and add in some way to make 10. So this is the most common wrong way to do it. People say, well, 6 and 4 makes 10. If I make them both negative, that'll give me a negative 10. The problem is when you FOIL that, that would be a positive 24 for your last term, and you want a negative 24. So we need to rethink this. Let me just erase all that. So instead of thinking 6 and 4, what about 12 and 2? If I do a negative 12 and a positive 2, that still gives me the negative 10, and it still multiplies to give me the negative 24. So now I'm factored. Now I'm ready to solve. So I set each factor equal to 0, and I get a 12 and a negative 2. Neither one of those are my restriction of 0, so I get to keep them both. So I have two solutions. All right, so let's try the same thing for B. So if I think about an LCD, I have an x minus 3. I need that. The next fraction has an x. I need that. But notice this last one, if I factor it, that's just x times x minus 3. So I've already got that. My restrictions, x minus 3 would be 0 when x is 3, so 3 is a restriction, and 0 itself is a restriction. All right, so now I'm ready to clear my fractions. I'm going to rewrite this since I kind of wrote all over it. All right, so I'm going to do the factored version. All right, so now I'm ready to clear my fractions. So each fraction gets multiplied by the LCD, which is an x and an x minus 3. All right, so if I've done this correctly, all of my fractions should fall out. The x minus 3's cancel, and I get 3x times that leftover x. Here the x's cancel, and I get a minus 4 times x minus 3. And here all of that cancels, and I get a 12. So that gives me 3x squared minus 4x plus 12 equals 12. Now I need it in standard form first, which means I need it equal to 0. So I get 3x squared minus 4x, and then this zeroes out, so I just set that equal to 0. So you could do quadratic formula here. I think factoring is easier because all you have to do is take out an x, and that's fully factored. So I set each factor equal to 0. I get x equals 0, 3x minus 4 equals 0. Okay, so I've got my two answers. I do need to check against my restricted values. So if I get an answer of 3 or 0, I have to throw it out. So notice I did get one here. This is restricted. Okay, so I'm going to throw that answer out. So I only have one answer, and it's going to be x equals 4/3.